Yeah. Hi, everyone. We're from Team 4A, Project Group 4A, and we'll first start with our introduction. I'm Yashaswini Vasudevamurthy, and my expertise is in front end. The languages for programming which I'm comfortable with is Java, C++, and for database managements, I'd like to work with SQL. That's about me.
I'm Prem, and my expertise is in full stack development and Internet of Things. And I have worked on the UI as well as AES module of this project that we've implemented, and everything that work that I have done, and all three of us have put it on our GitHub repos, which is mentioned in the slide. Muskan, you're up next.
I'm Muskan Manocha, and ML is what interests me the most. But apart from that, I am into automation and backend as well. And apart from that, a general point is that I love to code in Python, and I love that our project was also implemented in Python. So let's go ahead and talk more about our project.
So talking about what our project was intended to do is implement the encryption and decryption algorithms. We were basically expected to work on RSA encryption, decryption, signing, and verification, AES encryption and decryption in CTR 256, and base encoding and decoding techniques. We were allowed to choose the language with which we wanted to work on, and we chose Python for that. The basic reason that we chose Python was because it has some inbuilt libraries which will be very useful for these encryption and decryption techniques.
So, to summarize what the project was, it's the use of different encryption techniques that Atsign uses, and the main project that we used for a reference was at Java. So everything that Atsign has done is in the Java, and then the version that we are implementing is Pythonic version of this encryption utility. So eventually, the goal is that when Atsign does end up making a at Python a client, they'll end up using the encryption tool that we have developed. And any other SDKs that were written in Python can and which need encryption utility can use the project that we have done.
So let's talk about the project timeline before we actually start to talk about the project. So we had an iterative software development model. So as you guys should know, that it involves some initial planning, and then there are iterations of more planning, implementation, testing, and then so on and so on. And then of course goes on to deployment. So in the initial planning, we finalized Python, of course, and then we went through all these algorithms. Even in the previous group, they talked about the same algorithms. So we just got to know the gist of them. Then we went through the Atsign repo and the encryption stack, which was expected from us. Then we moved on to the implementation part. So we just, in the beginning, we just started to, just concentrated on the functional part of it, whether which library is better, which library is not. Some libraries were not compatible with the latest versions of Python, so we had to scrap them out, and then we found it out. And later on in the second iteration, we structurized our code well, just combined oops and all the pep8 recommendations and built a nice utility. And then in the iteration 3, we got to collaborate with another group, which is going to present later on. They worked on the Python SDK. So our Python encryption was directly used by them. So we got to do that. And then we made the test scripts, which included unit tests, negative tests, and functional tests. And then, of course, we optimized our code and then deployed it. So yeah, let's move ahead and get to know more about the project.
So our project mainly uses two encryption decryption algorithms. One is RSA and one is AES. So I'll first talk about RSA. So the RSA encryption algorithm is an asymmetric algorithm, which means it uses two types of keys. One is the public key and one is the private key. So public key by its name, as its name says, is used to encrypt the data, and the private key is used to decrypt the data. The advantage of this is that the private key, so as it says, it's private, and only the intended recipient is able to decrypt the data. Even though the public key is going to be available to everyone, decryption is not possible. So this makes the algorithm very secure. And since RSA is very computationally intensive, its coverage is low, which means it can encrypt only small amounts of data and not very large, unlike AES.
Speaking of AES, AES uses symmetric encryption unlike RSA. So there is a single key that is used for encryption and decryption. So it means that the recipient cannot be verified because they do not have the concept of private key does not exist.
I
But
think
hello, hello.
continue.
Yeah, okay. Yeah, but then what AES lacks in the verification front, it makes up for it in terms of coverage. So like yeah, RSA is not does not have a large coverage as Yashashwini said. So, but AES, the amount of data that AES can encrypt is practically unlimited. So, the solution that we developed uses the strengths of both and sort of addresses the weaknesses of both of them for the entire encryption utility. Hello, Muskan?
Sorry. Yeah, I was on mute. Anyway, so this is the stack. So I'll just explain it to you in simple terms, and you can obviously read while I explain. So here we combine that one key from AES and combine it with RSA, public key and private key, in such a way that first the AES key and the initialization vector is generated. That encrypts the text to be encrypted. And then we generate the RSA key, where the public key encrypts the AES key. And now, so this combination of encrypted AES key, public RSA key, and our encrypted plain text is sent from the sender side. And the receiver has the private RSA key to decrypt the AES key and then again decrypt the message. So that is how that's the gist of what the encryption algorithm is. And then we implemented it in such a way that we, if there are any changes in the future, like if you want to, incorporate another or, another encryption algorithm or just switch. So our class structure is basically, okay, you know what, I will show you the code, but before that, Prem has to, can you
Yeah,
stop?
yeah.
Or yeah.
Muskan, I got this. Yeah.
Let's show
So,
the first.
yeah. So, there's a demo that I would like to show. We have actually implemented a UI that uses the encryption utility that we developed, and it sort of prompts user for a string. So we can just enter a string, and then how the encryption mechanism that we have implemented treats the string from the on the receiver's end and on the sender's end, we can sort of get a idea of what it does. So, Tyler, you want me to use the same sentence that we used earlier? Hello?
I think
Any
you sent.
any any input? Hello?
Right, I like pizza.
Okay.
Oh, I don't like pizza with pineapple. That's gross.
I'm sorry, I do. Okay. So, so this is how this line separates, by the way, from senders to receivers. So like if I have a string that is entered, first it's gonna encrypt it using AES algorithm, and then the way it looks like is this absolute gibberish, and then we encrypt the AES key itself using RSA. So that key is not like, even if the message is intercepted, no one can use this key to decrypt this. And then on the receiver's end, they'll use their private key to first decrypt this AES key, and then the decrypted AES key can obviously be used to decrypt the encrypted text, and that is how this UI shows how our utility works. I think I can stop sharing. Yeah. So tools and technologies.
Yeah.
Yashasvi,
Yeah. So the tools and technologies that we used for our project are Python for coding, as we mentioned earlier. We chose Python because it consists of libraries which will be useful for our RSA, AES, and base64 encryption decryption technologies. We used VS Code as the framework for work on. And PySimple GUI, we used it just for the UI presentation that Prem just showed up in this demo. That was just for the sake of demo that we did. GitHub, we used it for collaborating, as everyone knows. And Markdown is a scripting language, and we use Markdown for working on the documentation and README.
a sample use case. So like the project group. So here in this section, we had to put the one use of the project that we did, and that's literally project group one because they were developing Python SDK. So and their work required encryption utility. So everything that goes on the encrypted side on their project has been the work has been the utility that they use from us. Speaking of learning outcomes, Yashashwini, you want to go first?
Yeah. So about the learning outcomes, well, first and foremost, we learned about the cryptographic techniques. Though we knew the RSA or AES algorithms even before this, it was not like we had a very deep understanding about it. But with this project, we did get a very good knowledge about it, and we also got an opportunity to work hands-on on it. So it's always like when you work on it, the experience that you get and the knowledge that you gain is more than just knowing about it. So we did get a lot of knowledge about the RSA, AES, and base64. We also learned about the SHA-256, which is the hashing algorithm that we have used in RSA. So we learned a lot about cryptography and it's the techniques that we've used here.
There are many more things that we learned. For example, SDK development. So like we have all attended the lectures and we know what agile development is. But then throughout the semester, we implemented an iterative model, and then we have been implementing work and then going back to correcting it. So like we have been in the process of agile development itself, and there was a lot to learn. Needless to say, we did learn a lot about version control since we were collaborating with other groups. So like there were often pull requests, they merged it, and then they recommended some changes, and then so like that covers the version control aspect as well. And yeah, Muskan, anything else you want to add?
Yeah, just we learned about the testing as well. And I think at every iteration, testing was very important, although there was different types of testing, even debugging. And of course, collaboration, the inter and intra team collaboration was very important. And I would say that just to maintain an efficiency in that area was, I think I'm happy with this, the efficiency we maintain throughout the semester. So thank you. Thank you for giving us this opportunity. And now I would like to show you the code base just a bit, just a tiny bit, so you understand what we did. So we have one abstract class that is the encryption.py. That is just to create a good structure for other classes. And every encryption algorithm will have its own class, which will, of course, implement encrypt and decrypt function. Yeah, and I think we try to maintain all the PEP8 recommendations according to Python and used Python properties and decorators to as much as we could, because in some places it was required to have, like getters and setters in terms of keys and the key pairs that was there. And yeah, so this is the basic utility. Now this utility inherits from the different encryption algorithm classes. And this utility is what will be used by our client or whoever uses this And
So
yeah,
like these classes, Muskan, if I may, these classes implement the AES and RSA logic, and then there is a class encryption util.py that is like this is intended for other SDK developers. So like whoever wants to develop an SDK and wants encryption, they just need to call the methods from these encryption underscore util. It has implementation of AES and RSA combined. I think that
we can briefly show the tests as well.
sure. So
Yeah.
do you want me to run them?
Yeah, you can run them. Or I've
Sure,
also we've also pasted the output just in case. Anyway, so Python, the unit testing, we've just used unit tests, but along with the logging class of Python, which I personally like because it's very you can just you don't have to go back and debug again and again, even if one test is failing. So yeah.
So there are a lot of tests that we did. For example, one, it sends a text and then it goes through entire encryption algorithm, and then on decryption side, it again decrypts it, and then like there are multiple tests that do it.
So
like,
these are the unit tests. There are functional tests and as well as negative tests.
Yeah.
Yeah.
So like we implemented 7 tests, all of them passing.
I think that's it, guys. Let us know if
we can
questions.
we can open the room for questions. Right?
Yes.
Okay. Hi everyone, we are group 1. We have developed AD protocol for Python. Let me first introduce the nerd squad. My name is Umang Shah and I am a problem solver and Python developer with keen interest in artificial intelligence and computer vision. My main focus in the project was to develop code architecture and code optimizations. Now Rudresh can introduce himself.
Hello everyone. Hey guys, I'm like a software engineer at like a database company, and I like really like to solve like hard algorithm based problems. And for this project, I was like focusing on the protocol side of things.
Hey guys, I'm Varun Shimbekar. I'm mainly a React.js and Ruby on Rails developer, but on this project, I've been working mainly on the socket connections and the testing part of things. Over to you, Umang.
Okay. The aim of our project was to develop a library for AD protocol in Python. The library can be used to add security to existing and new Python applications. The AD platform provides unique identifiers called Atsigns. Using these Atsigns, different entities can communicate with each other in a secure way. The communication is encrypted using AES and RSA encryption. The AD protocol provides verbs for interacting with Atsigns. The Python library implements those verbs and returns results based on that. This project is kind of a main project because we try to develop those communication verbs and learn how the AD protocol works. The reason we chose Python as our development language is because it is the most popular language nowadays. Since most of the websites and applications are in Python, we can capture a large audience. Now Rudresh will show us a cool demo of the project.
Let's do it. Awesome. So I have like two terminals opened up. And then let's import our cool SDK into the terminals. And now I'll start with like very simple demo of, let's say, if a Atsign wants to update a key and then just look it up by itself. So first we have to like upload our personal keys, individual Atsign keys. Then this Atsign, we have to create an object of Atsign, which will connect with the root server, get its own secondary server, and successfully connect it with it. Now we have to authenticate ourselves with the secondary server so that we can like start using all the protocols. So this is like all the communication we did to authenticate ourselves. Basically, the server sends us a challenge, then we have to like decrypt it using our encrypt it using our keys, send it back to confirm that it was us. Now let's do a local update for ourselves. Let's choose key as foo, value as bar, and upload. Now this key value pair has been uploaded to the secondary server, and now we should be able to look it up. Nice, we got the bar back. Now, if you want to do communication between two users, so similarly, we have to like set up another user, load their keys, create @sign for the second guy. We got the secondary server. Now we have to authenticate ourselves. Authentication is done. Now let's try to send some message from this universal to this immature guy. We'll use this update protocol. Key is hello, world is the value, and this is the location where we want to share it with. Then it is being shared. Now we can like look it up on the other end. Right, so we got the world back. And this was not encrypted. But now, what if we want to communicate securely? So for that, we can use secure update method. We'll use our keys to encrypt our data. Foo bar is the key value pair, and this is where we have to send. And you can see it will be like a bit longer communication. Basically, we have to like look up if the other guy has shared a public key with us. If not, in this case, it wasn't. So we will like look up its public key, encrypt the data, create AES key, encrypt the data, share the key with the other user, and send the data. So now you can see the data was like fully encrypted and it was not like bar or simply bar, so other can see. Similarly, the other guy should be able to look it up. Again, it will like look up the shared key, it got the shared key, look up the key value pair, and then it will finally decrypt and get the value. And I want to like quickly talk about some of the cool optimizations we did along the way. In the initial phase, our @sign object, whenever you create an @sign object, it was creating a new connection to the root server every time a new @sign object is created. But then we figured out like we can do this optimization where we can just create a single @sign object or single @sign socket connection with the root server, and then we can like reuse it to get multiple secondary server based on the number of objects we create. And then I think Varun can share more ideas.
So while we were starting out with the project, we began by reading a lot of the documentation from the Atsign client. We looked through the work they had already done for Dart and began planning out how we would add support for Python. There were a few challenges, mind you. Previously, each Atsign was required to establish a new socket connection to the root server, which was inefficient and resource intensive, like Rudresh said in the past slide. However, we have successfully optimized the code to allow multiple Atsigns to establish connections to the root server using only a single socket. This optimization has not only improved the overall efficiency of the process, but has also reduced the resources required for establishing these connections. In the end, we got a good grip of how to deal with socket connections, how to implement RSA and AES encryption techniques. Over the course of building the project, with constant support from Tyler and Jeremy, we were able to put together a version of what we think they wanted. And to wrap up, I'd like to thank Jeremy, Tyler, Professor Fletcher on behalf of our team for guiding us throughout the entire process. And if there are any questions or comments, my team and I would be happy to answer them.